Hello and welcome to your Unit 2, Lesson 6 Notes, solving equations with variables on both sides. Before we begin, let's do a little warm-up. So we're going to simplify these expressions by doing the distributive property backwards. So here we're going to undistribute what they have in common. I see that each of these has a p in common, so we're going to take that p out. And here we have 5 times p minus 1 times p, and we're going to pull each of these p's out. They're like 2 peas in a pod. So we have 5. Once we pull a p out, we're left with 5 minus 1, and that gives us 4p. And this makes sense, right? If we have 5 people and we take away 1 people, we just have 4 people left. Now on this one, what do they have in common? Here they both have an n in common. So we can pull that n out, giving us 3/4 minus 1/4 n. We took the n away from each of them, and now we just have 3/4 minus 1/4 n. Now 3/4 minus 1/4, that is 2/4. So that gives us 2/4 n, and 2/4 is the same as 1/2. Because we can take out a 2 by dividing by 2 on top and dividing by 2 on bottom. That simplifies to 1/2. So we have 1/2 n. If you want to leave it like this, that's fine. If you rather have n divided by 2, that's also fine. And finally, with our third example, we have 18x plus 3x. We can take the x out, leaving us with 18 plus 3. X is on the outside, and 18 plus 3 is 21. So our final answer here is 21x. Now, undistributing, or in this case, combining like terms, is important to solve equations when you have variables on both sides. So our key idea of the day today is that if you have variables on both sides of an equation, first you need to add or subtract to get all the variables on the same side. So let's do that. Here we've got 5x equals x minus 12, but we need to get all of our variables on the same side. So we're going to add and subtract. First, I'm going to subtract an x from both sides. So on this side, x minus x, that cancels out. We're left with negative 12. But on the left side, we have 5x minus x. Well, what we can do is we can take out x, and that will give us 5 minus 1x, which is 4x. So 4x equals negative 12. Now we're almost done. Remember, we need to get x all by itself. So we need to undo what's happening to our x. Here we have a 4 times. So to undo that, we are going, you know what, I'll make that a different color. To undo the 4 times, we need to divide both sides by 4. So we divide by 4, and that leaves us with x equals negative 3. Whenever we solve an equation, it's very important that we check our solution. So we're going to check our solution by substituting it back in. So I claimed earlier that x equals negative 3. So I'm going to take x equals negative 3 and plug it back into the original equation. The original equation said 5x equals x minus 12. So let's plug in x equals negative 3 and see if that's true. So is it true that 5 times negative 3 equals negative 3 minus 12? Well, we're not sure, we're checking, so is that true? Well, 5 times negative 3 is negative 15, and negative 3 minus 12 is negative 15. So yes, that's true, we did it right. Let's do it again. Okay, here we have s's on both sides of our equations, just of our equals sign. There's one equation. So we need to add or subtract to get rid of that 1/4. Now, it doesn't matter what side you have your variable on. I usually pick which one is bigger and I stick with that. So I want to keep this side on this side because 3/4 is bigger than 1/4. So I minus 1/4 s from both sides. And then they'll cancel out on the left. So we just have 16 equals 3/4 s minus 1/4 of s. Then we take the s out, so we undistribute that s, giving us that 16 equals 3/4 minus 1/4 s. Now what is 3/4 minus 1/4? I feel like we just did that. We did. Okay, that's 1/2. 2/4 is 1/2. Oh, now we have 1/2 s. How can we undo 1/2 times s? Well, there's two ways. One, we could divide by 1/2, but you guys, dividing by 1/2, oh, that's so gross. Dividing by fractions, yuck. When we divide by fractions, we just multiply by the reciprocal. We multiply times 2/1, times 2/1. Let's do that instead. In fact, that's just the same thing as times 2, so we'll do that. Now, 1/2 times 2, those will cancel each other out. That's gone, so we're left with just s. And 2 times 16 is 32. So I claim that s is 32. Did I do it right? Well, let's check. Is it true that 16 plus 1/4 s equals 3/4 of s? Well, remember, we claim that s is 32. So let's plug 32 in for s and see, is that true? Is it true that 16 plus 1/4 of 32 equals 3/4 of 32? Well, 32 divided by 4 is 8. So we get 16 plus 8. Does that equal to 3/4 of 32? Wow. So let's do 3 times 32. Nope, 3 times 32 divided by 4. 3 times 32 is 96. And 96 divided by 4, here this before, is 24. So yay, we did it right. Awesome. Cool. So yeah, that's the first half of our notes. Make sure that you're adding and subtracting to get all the variables on the same side first. Now, in 2018, the World Championship 100-meter dash times were 10.03 seconds for men and 11.07 seconds for women. If each year the men's time decreases by 0.4 seconds and the women's time decreases by 0.12 seconds, did I say 0.4 or 0.04? Because I definitely meant 0.04. Then when will they have the same winning times? Well, let's set up an equation first and then find out. So we're going to say that y is the year after 2018. So we're going to say let y equal the number of years after 2018. Okay. Then we start out with the men. We have 10.03 is their starting time, and it decreases by 0.04 every year. So every year it goes down 0.04 seconds. Following the same pattern, we want to find out the women's time. So the women's time is 11.07 seconds, but it's been decreasing by 0.12 seconds every year. And we want to find out when are they going to be the same. So we set them equal to each other. Well, there you have it. We've got our equation. Now we just need to solve it. fact, I'm going to make it smaller as I try to solve it. Move this here. Okay, so our first step is we want to get all the y's on the same side. So we have y's here, and we have y's here. Now I like to deal with positive numbers, so I am going to add 0.12y to both sides. I could have added 0.04y to both sides, but then I would still have a negative. So it doesn't matter which one you do as long as you do the same thing on both sides. So we have 10.03 plus 0.08y equals 11.07. Now remember, our end game to solve an equation is to get y all by itself. So our next step is to undo adding 10.03. So we're going to undo that by subtracting 10.03 on both sides. On the left, it cancels out right away. That's why we did it. So we're left, no pun intended, with 0.08y equals 11.07 minus 10.03 leaves us with just 1.04. That's so fun. And then in our last step, remember, we want to get y all by itself, so we're going to undo this 0.08 times. So we're going to divide both sides by 0.08. And in doing that, we get that y equals 13 exactly. How fun is that? Exactly 13. So what does that mean? Does that mean that they'll have the same winning times in year 13? No. We said y is the number of years after 2018. So we need to take 2018 plus 13, which gives us 2031. So in the year 2031, the women will catch up with the men. Okay, cool. Now we have two more things to look at. First, let's solve these guys. What happens if you have an equation like this? Well, here, remember we have 7x over here, 7x over here. We want to get them all on the same side. So I'm going to subtract 7x from both sides. So I minus 7x here, minus 7x there. And those will cancel out, leaving me with just 2 equals 9. Oh, but that's false. That's not true. So we say this equation has no solution. That means that no matter what we plug in for x, no matter what we put in here for x, it will never ever be true. So it has no solution. What about here? Here, let's see, we've got our t's over here. We've got plus 16 over there, so I'm going to minus 6t from both sides. Okay, that leaves us with 4 minus 9 equals negative 5, and then we can clean that up. 4 minus 9 is negative 5. Negative 5 equals negative 5. This is always true. We must have done something wrong. Let's do it again. This time instead, we're going to combine all the numbers first. So we have 4 minus 9. Well, let's rearrange them. So we get 6t plus 4 minus 9 equals 6t minus 5. And then 4 minus 9 is 6t minus 5 equals 6. Oh, I rewrote this wrong. 5. 6t minus 5. And then we can undo that by adding 5, wrong tool, adding 5 to both sides. Up here, so plus 5, so we get that 6t equals 6t, and then we divide by 6 to get rid of the 6 times. Oh, and you guys, we are left with t equals t, and that is always true too. How weird. Notice that no matter what we did, we got the same answer. We got something that is always true. So no matter what we plug in for t, we'll always get a true statement. So an equation that is true for every value of the variable, we call this an identity. For example, if we have the equation t equals t, that's always true. Or, 5 equals 5, that is always true. Or -8 equals -10 plus 2, that is always true. We call that an identity. Now here's one more. Say that I have a number in mind. I'm thinking of a number, and 3 times that number, excuse me, I have the hiccups. 3 times some number n is equal to 24 less than 5 times the number. I'm running out of colors. Less than 5 times that number. Oh, that same number. We're going to write an equation to represent the problem. And in doing so, we're going to translate each of those parts into math. Okay, so when we have this 3 times, well, that's 3 times some number n, we just write, oh, n, some number n, means equals 24 less than, means you take whatever that is and then you subtract 24 from it. 5 times that number is 5 times whatever that same number, we said that number was n, is. Now we have a lot of space, so I'm going to rearrange them real quick. 3 times n equals 5 times n minus 24. And now that looks like a circus. So I'm going to copy it and make them all the same color. And here, I don't need the 3 times n, the 5 times n. I can just put them right next to each other, which gives us 3n equals 5n minus 24. And now we want to solve. What is n? Well, first I want to get all of my n's on the same side. So I'm going to subtract 5n from both sides. So on the left, that gives me negative 2n equals 0 minus 24. Now we're almost done, except now we have negative 2 times n. So to undo that, we're going to divide by negative 2. Divide by negative 2 on both sides, and we'll cancel out on the left, leaving us with just n. And negative 24 divided by negative 2 is a positive 12, because a negative divided by negative is a positive. So n is 12. Now that means that 12 is the solution to our problem up here. Is it true? Well, let's check our work. Is it true that 3 times the number 12 is 24 less than 5 times the number 12? Let's find out. What is 3 times 12? That is 36. I'm asking a question, is 36 equal to 5 times 12 is 60 minus 24? Why, yes. Yes, that is true. So yay, we did it right. Super duper. So remember, whenever you're solving an equation, make sure you get all the variables on the same side using addition or subtraction. I hope you have a wonderful time on your homework.